Why Lamborghini V10s are way too overpowered. What would lead someone to take a machine with excellent performance and then double or triple its power output? Lamborghinis have always been at the top in terms of their power, but if you add a pair of twin turbochargers, adjust the engine control unit, and use some special fuels, you'll witness a miracle. There are even tuning firms that specialize in transforming what can be described as an average Lamborghini into a vehicle that can compete with Bugattis. But why are Lamborghini V10s way too overpowered? And how did the brand come to own such powerful vehicles? Owning and driving a Lamborghini powered by a V10 engine is an experience that transcends the ordinary. A symphony of power, precision, and exhilaration immerses the driver in a world where dreams become a reality. The unmatched driving experience of Lamborghini V10 powered vehicles is a testament to the relentless pursuit of automotive perfection. From the moment you slip behind the wheel of a Lamborghini V10, a sense of anticipation takes hold. As you turn the key, the engine comes to life with a roar that ignites your senses. The rumble reverberates through the cabin, and you feel the power pulsating beneath your fingertips. It's an invitation to embrace the unbridled energy that lies dormant, waiting to be unleashed. The acceleration is nothing short of breathtaking, and it launches you into another dimension. The force pushes you back into your seat, and the world outside becomes a blur. As you navigate the open road, the handling prowess of the Lamborghini V10 becomes evident. The vehicle responds to your slightest input with surgical precision, seamlessly translating your intentions into action. It dances effortlessly through corners, hugging the road with its tenacious grip. The advanced suspension system absorbs imperfections, ensuring a smooth and controlled ride even at high speeds. It's a harmonious fusion of power and control, allowing you to push the limits of performance while maintaining a sense of confidence and stability. But how did Lamborghini get to such perfection and glory? The story begins with Audi, which paid a total of $110 million to acquire Lamborghini in the year 1998. Because they had an exceptionally talented engineering team of professionals such as Maurizio Reggiani, who was involved in developing the quad-turbo V12 engine, they successfully transformed Lamborghini into a global powerhouse. Lamborghini started working on an entry-level Baby Diablo, eventually becoming the Lamborghini Cala concept car. The Lamborghini Cala concept car featured a mid-mounted 4-liter V10 engine, a 6-speed manual transmission, a carbon fiber body, and an aluminum chassis. The Cala never reached its full potential, but later served as the foundation for the Lamborghini Gallardo, which became its spiritual successor. This new Gallardo's power plant was an evolution of the Cala's V10, bumping up from 4 liters to 5 liters in displacement using an Audi cast aluminum block with an undersquare bore and stroke configuration and a special crankshaft featuring an 18-degree offset crank pin, giving it an even-firing pulse every 72 degrees of crankshaft rotation. The Gallardo had a traditional drivetrain, and drivers had the option of selecting either a conventional gated 6-speed manual or an II gear, an automated manual with a single clutch, and was comparable to BMW SMG transmissions in 2003. The Gallardo was originally introduced for the 2004 model year, and its first-year sales were twice as high as those of the flagship V12 Lamborghini Murcielago. These results indicated that Lamborghini had a new hot-ticket item, and it wasn't long before owners began to investigate the capabilities of this beast. Performance shops quickly jumped on the Lamborghini to investigate the possibility of dual turbochargers on the Gallardo. Jason Hefner established his name in the industry by effectively boosting fragile exotic vehicles, such as Lamborghini Diablos and Vipers. In 2005, Hefner designed the Twin Turbo 700, which uses twin water-cooled ball-bearing turbos to force 10 pounds per square inch of air into the Gallardo's V10. The factory pistons were replaced with forged disc pistons, the compression ratio was lowered, and the engine produced 700 horsepower and 505 pound-feet of torque. This allowed the Gallardo to complete the quarter mile in 11.4 seconds, a full second faster than the one with the factory setting. This was a $55,000 tweak that turned the baby Lamborghini into a giant killing machine. As the years went by, Hefner developed the Gallardo even further with 900 horsepower, 1500 horsepower, and even 2000 horsepower packages. The new V10 installed in the Gallardo had very few similarities to its predecessor. The old engine had a larger bore spacing of 90 millimeters, giving it a displacement of 5.2 liters. Additionally, the crank pins were not offset, which prevented the V10 from having uneven firing intervals. So this resulted in a discernible change in the engine's sound. This new engine architecture was more resistant to failure, and it was even more possible to use force induction. The second generation of the Gallardo was released in 2008 with a 5.2-liter V10 engine that could be paired with either a 6-speed Graziano manual transmission or a 6-speed E-Gear Graziano automated manual transmission. With the addition of their twin turbo packages, which featured 2 huge 72mm billet turbocharges, a firm known as UGR or Underground Racing took the vehicles to even greater heights. The list of available improvements was extensive and, as one might expect, quite pricey. Their total cost was comparable to that of the vehicle itself. These packages excelled at breaking global records in terms of their ability to stand out from the crowd. Similar to how impressive Gallardos were in racing competitions, they were also formidable opponents on the street. Because the vehicle had a permanent all-wheel drive system, the Gallardo could put all the power down to the wheels with minimal wheel spin. The Gallardo cemented the model's position as the most successful Lamborghini model, and its successor would have to have something even extra to replace the Gallardo. In 2014, Lamborghini increased the standard by developing the Huracan LP16. This was primarily engineered from a technological standpoint, as it featured torque vectoring all-wheel drive electric power steering and an all-new 7-speed Lamborghini dual-clutch transmission. The V10 was also improved by having a greater compression ratio of 12.7 to 1 and dual fuel injection, where the direct injection would activate in high engine load circumstances and the multi-port fuel injection would run in low load settings. Because a significant portion of the engine architecture was inherited from the tweaked Gallardo, the acceleration of the development of force induction Hurricanes reached a new high. This was not the most powerful or the best engine available, and it was quickly replaced by monsters such as the Scion FKP37 and the Scion Roadster. The 6.5-liter naturally aspirated V12 found in both Scions is combined with a 48-volt electric drive, making it more luxurious and providing a smoother ride overall. The FKP37 and the Roadster had 800 horsepower, which is very serious business. But the V10 was a unique engine that still holds a special place not only in car manufacturers' hearts, but also in gearheads' hearts. It's extremely rare, much rarer than the V12, and it frequently occurs in a few variations today. But what really makes the Lamborghini 5.2-liter V10 engine stand out from the competition? For starters, the ambiance created by the noise coming from the engine is a significant component of the supercar experience. And this is where turbos and smaller engines simply cannot compete with the symphony produced by a naturally aspirated V10, such as the 5.2-liter unit found in the Lamborghini. The V10 often provides greater RPM because its intakes are not constrained in the same way that turbos' intakes are during turbo lag. We're not trying to disparage turbos or larger engines, we are merely elaborating on what sets the Lamborghini V10 apart. We do not dispute the fact that a V12 engine is inherently better balanced than a V10 engine since there is no requirement for a balanced shaft. However, the V10 consumes less fuel at the same power level as a V12, although this may not be the case if the V10 has a balancing shaft to smooth out the vibrations in the engine. In addition, the Lambo's V10 is a superior choice in situations where a V8 would not be adequate in terms of power output, and the V12 would either be too massive, too expensive, or much more complicated. You could say that the V12's increased number of moving parts creates more potential for reliability issues. The V10 obviously has fewer cylinders than the V12, which results in a more compact design. Additionally, depending on the size and type, the V10 does not experience the pumping and friction losses associated with the V12. Compared to V12 engines, which have an ideal V-angle of 60 degrees, the 5.2-liter V10 engine in the Lamborghini gives an outstanding balance thanks to its 90-degree layout. In contrast, most V10 engines have an optimum V-angle of 72 degrees. Most automotive manufacturers pick the V10 partly because of its heritage in motorsports. Going back to the heyday of Formula One racing in the 60s and 70s, the automobiles used in Formula One were more shrill despite their decreased size and increased speed. It was also the reason that the Formula One races of the 1960s were filled with gruesome wrecks that were both unforgettable and heartbreakingly sad at the same time. The naturally aspirated V10 with 3 liters was most commonly seen in Formula One since it was more compact and quicker. Ultimately, the Lamborghini V10 might not be the best car for daily driving, but it has a top speed of 200 miles per hour and costs less than $200,000. This delicious combination can only be provided by a V10 engine. That's all from this video. What do you think about Lamborghini automobiles? And would you like to own this one? See you in the next one.